Hello, here's a quick introduction or review on how to find the number of protons, neutrons, and electrons. So here we have our practice handout. You do need a periodic table to go along with this, if you don't have your periodic table ready, you can go to this website called ptable.com, and it has a pretty fantastic periodic table that you can use for reference. Cool, let's go back to our worksheet. So the first one we have is boron, and we are trying to find the atomic number, protons, electrons, mass, atomic mass, and the nucleic notation. Here are some key things to remember. So we have our mnemonic ape-man, where atomic number equals proton, which is also equals to the number of electron, only on the case that the atom is neutral. So for this section, this is a special case, but atomic number and proton will be always the same. So that tells me I need to find B for boron. So go to my periodic table, which is currently loading. Boron is number 5. Atomic number and protons will always be the same, so this is also equal to 5. To find the number of electrons, I can see that I have a positive 2 charge. Because I have a positive 2 charge, that means I have extras of positives. And we know that our positives are our protons and our negatives are our electrons. So we have 2 extra positive. Once again. So here I have 5 protons and I have 2 too many. So that tells me I should have 3 electrons. Mass number is the next thing that we have here. Mass number is different from atomic mass. So mass number is the number of protons in this case plus the number of neutrons. However, if we were to look at the atomic mass is actually the mass found on the periodic table. So first, let's do the mass number. So for the mass number, we're adding up our protons and electrons, which is 5 and 6. So 5 plus 6 tells me that I have 11. Okay, let's go to our periodic table to find the atomic mass for boron. So boron is number 5. The mass is 10.81. Cool. And the last one is our nuclide notation. Nuclide notation is something we haven't really covered just yet, but it's a way to represent all of these information here. So in nucleic notation, we have a way to write it, and I'll search it up just so you guys can also see it as well. So nucleic notation, we have the symbol representing X, the atomic number in Z, and the mass number in A. So A, Z, and X. So for this question here, we have B for boron, On the top will be the mass number, which is 11. And the bottom is the atomic number or the number proton, which is 5. And another thing I want to add is for some nucleic notation, you actually write down the charge. The charge for this is plus 2. Okay. So that's one way to do it. Let's try some more. Let's try this one with a 63.5. So sometimes you're actually not given the element, right? We don't have symbol, we don't have atomic number or the protons, but we have 63.5. So we can look at our periodic table and find which element has 63.5, and sometimes approximate. So here we have copper, which is number 29 on the periodic table, and it does have 63.5. So we know for this one, the symbol is copper, number 29, and we'll put that as protons and atomic number are the same. Now I'm given neutrons, and I can use the number of protons and neutrons to figure out my mass number, so I have to add them together. So 5 plus 9 is 14. This is 64. Cool. To figure out the number of electrons, we once again look at the charge. So charge is -1, meaning we have more electrons because electrons are negative. And that would be 30. So 30 minuses and 29 positives results in a -1 charge. And the symbol for this would be Cu. You know it's -1. Mass is 64. And the atomic number is 29. Okay. So continue working on this worksheet here. Please let me know if you have any questions. Thank you.